Which of these forces keeps the moon moving around the Earth? Well, gravitational, obviously, moon orbits due to gravity. Which of these is a scalar quantity? So, scalar quantity is something which only increases in size. For example, mass can only increase in size. It doesn't have any, or it's not related to direction. So, a vector quantity is something which can change in magnitude and size and direction. So, vector quantities often have a positive or negative value to indicate which direction they're moving in. Negative means they're moving in the opposite direction to positive, which is like the forward direction. So velocity is a vector value. It has magnitude and direction. Momentum is a vector value. It has direction and magnitude. Acceleration is also a vector value. It acts in a specific direction, but energy is not. It's a scalar value. The other one that comes up frequently is displacement and distance, and you need to know that displacement is a vector quantity and distance is a scalar one. Figure 4 shows a box at rest on a floor. The force that the floor exerts on the box is shown by the vector in figure 4. So vector is anything acting in a direction. So this is a vector arrow. Add another vector to the diagram in figure 4 to show the weight of the box. So we can see that the force is being exerted here. Now this box is not moving, it's a stationary box, it's an equilibrium, so that means there must be an equal and opposite force acting in the other direction on here. So you should, to get the marks, it have to be the same size but in the opposite direction. So this is weight here, and this is the normal force because it's an equilibrium, the normal force here. Figure 5 shows part of a car. When the wheels turn, the axles become warm. So this is about energy transfer. Explain why the axles become warm when the wheel turns. So when things turn, there's friction, and friction creates heat, or it causes transfer of energy to heat. So you would just say friction between wheels and axle causing heat. Remember, this is an explain question, so you have to say what's happening and the effect of that. Give one way of reducing the heating of the axles when the wheel turns. You can just use common sense. If you want to reduce friction and therefore the effect it has, which is heating, you just use an oil or lubricant. Complete the equation that relates efficiency, useful energy transferred by a device, and total energy supplied. So you have to tie all these things into equations. So they put efficiency there for you. So I'm underlining every important part. So efficiency is useful energy transferred by the device. So useful divided by total energy in. So useful out divided by total energy in. And it's important to know that, otherwise you do not get this mark here either. So you lose a number of marks if you don't remember that. So when you're doing maths equations, always underline the important figures and pay attention to the units because it helps you understand what's what. In 1 second, an engine has a total energy input of 7,500 joules. So total energy input. In 1 second, 3,200 joules is transferred to the surroundings as wasted energy. That's really important to pay attention to that. Calculate the useful energy transferred by the engine. So actually, this is a bit of a trick. You might suddenly plug in these figures here and get the wrong answer. It's actually quite simple. You're trying to work out how much useful energy is transferred. Well, this is total energy in. If you take away the wasted energy, you'll be left with the useful energy. So you should get that. 7,500 take away 3,200 gives you 4,300 joules. So make sure you pay attention to what it's asking you to do. And now you calculate the efficiency of the engine. So let's just move this down here. So the efficiency is 4,300, as you can see here, which is useful energy out divided by total energy in, which will give you 0.57. You don't actually have to write a unit for this because the number is an efficiency rating, or you could write 57%. So remember, useful out divided by total in.